Okay, so this is your review sheet. You guys had a head start. I'll try to catch up. So, question 1. Mr. Walker wants to learn about students' favorite lunch option. Okay. Decide whether each method for selecting his sample will be random or biased. Okay, so 1, he selects 3 students from each homeroom roster and surveys these students. Let me just take this out. That should be, I would put that as unbiased, what do you call, random, right? As long as you select 3 students randomly from each class. That would be random for me. Selects every student in line A of the cafeteria and survey those students. That would be biased because you're selecting just a particular group, right? Everybody in line A. He uses a school directory to select 10 students grade from each level. That's definitely random and unbiased. Okay, alright, that's fair. Right, because everybody has the same chance to be selected. Places a survey in the school newspaper asking students to complete. That is not random, that is biased. Right, because only the people who are interested will respond, and therefore it's gonna favor, it might favor a certain answer. Okay. 2, local reporter is doing the story and community's response to a new Walmart being built in the area. Okay. Decide whether each conclusion is valid or not and explain your answer. So the report surveyed 4 people at a local gas station and concluded that the majority of the residents are opposed. So definitely, first of all, surveying only 4 people, it's definitely not enough to see how the community would respond. It's just not enough. And they're all in the same place, and those 4 people might be the same family member, the four friends who share the same opinion. So number 1, it's definitely not valid. Okay. Number 2, he surveys every 50th person from the town's phone directory. Okay, and concluded that two times as many people oppose the store. Okay, so definitely more fair. Everybody had a chance to be selected, random. Okay, so number 2, definitely, I think the conclusion is valid. Random and valid, I should write here. Okay. The reporter surveyed 100 people at a rally protesting the store. Okay, I'm going to just stop right there. So right there, you're surveying 100 people rallying and protesting the store. So all of them oppose the store to begin with. So they don't. It's definitely a biased opinion that all those 100 people will have. So definitely not random and not. So actually, we're not even looking for random. Just conclusion is not valid here. Right? Because you're just surveying the same group of people who share the same opinion. And the report surveyed every 3rd member of the city council and concluded that the town is evenly divided. Every 3rd member of the city council. Well, it depends on how many. That's a tough one. No, because the city council, although they theoretically represent, right, because we vote for them, and they represent the community, I don't think just surveying them to ask them about whether Walmart's it should be built or not, it represents the community. So I think this is not valid. Okay, because definitely not enough people. City council has, I don't know how many people, it's definitely not enough. Okay, people there to represent the whole community. 3, the table. So now I'm doing MAD. Okay, it shows the amount of rain. Find the MAD for both cities, city A and city B. Okay, so to find the MAD, the first thing, and let's do city A first. City A is 15 plus 19 plus 12 plus 24 plus 0, and divided that by 5, so it's 70. So the mean here is 70, by the way.
This is Joe.
Yeah.
question number 4, is it valid or not?
Say it again.
Is the last question you did valid or not?
Not valid. For number 2, I'm gonna say not. I would say not valid. You know, because you want what do you call the community response, not the city council. City council. It's like asking, you know, does junior high school 194 have a field trip every month? Should we ask the students or should we ask the teachers? I mean, you know, do we represent the voices of the students, or you know, I mean, I think we should ask only the students. You know what I mean, or should we even only ask the administration, meaning the principals? You know, so I'm gonna say no to that. Okay, because if you're doing a story on the community response, I think you should be asking the community, not the city council. Okay, the city council might have what, I don't know, 12 people, 20 people. Okay, so I'm still saying no to that, not valid. So over here, the mean, the sum was 70. And if you divide that by 5, you get 14. So the mean is 14 for city A. So I'm going to subtract, right? So again, to find the MAD, we have to subtract. So I'm going to do 15 minus 14 minus 14. Just going to put this in the front. Right, so we're going to find how far is each of these data, each of these points away from 14. It's 1 unit array, 5 units away, 2 units away, 8 units away, 14 units away. And then what do we do with these differences? We add them, right? So 1 plus 5 is 6. What is that number? 6, 8, 16. 16 and 14 is 30. So if I add all that, and then again I divide that by 5. So my MAD for city A is 6. Okay, not that bad. For my MAD so the mean for city B, so let's start with the mean. So let's add all that. So we got 15 plus 11 plus 17, and that equals 43. We can divide that by 5, and the mean is going to be 8.6. So for city B, the mean is 8.6. So again, I'm going to see how far 6 is away from 8.6, how far 9 is away from 8.6, etc. And so I'm going to subtract, right? So 8.6 minus 8.6 minus 8.6, and then minus 8.6.
Mr. Cho.
Yeah.
For city A, 24 minus 14 is not 8.
It's 10. So that's 10. So this is going to be 32. And then 32 divided by 5 is 6.4. Thank you. So the math 6.4. Thank you. 8.6 minus 6 is 2.6. 0.4. 2.4. 8.6 minus 8 is 0.6. And then 0.4. So again, we add them, and you can clearly tell the differences here are much smaller. And we'll probably get a lower match. That's 3 plus 3, 3.4. The total here is 3.4. And we're going to divide that by 5. And our MAD is 0.68. Oh my god. So what does that tell you? What does the MAD tell me about the data? Well, first of all, in terms of consistency, in terms of rain, city B has similar amount of rains for these 1 to 5 months. City A, has definitely a bigger change. Okay, variability in the amount of rain that the city receives in the first 5 months of the year. So if you are looking for a place, or you're planning to move somewhere for the months of January to May, and you're looking for somewhere that has, you want think about the amount of rain and how much it receives and the consistency and what to expect, you would definitely choose city B. Okay.
Mr. Cho.
Yeah.
How did you get 0.68?
I divided 3.4 divided by 5.
Isn't 3.4 supposed to be 6.4?
Of course it is, because I did it wrong. Ugh. Thanks. I have my own editor here. What's that? 3, yes, 6.4. 6.4 divided by 5. Maybe this live thing was not a good idea. Still a mat of 1.28. Okay. It's still lower than city A. Okay. Second part says, which city's MAD would affect more if the month of May was taken out of the data? Well, if you take the month of May out of the data, I mean, and if you look here, May here was 0 and May here was 9, right? It's going to make a huge difference from city A, right? Because if you take that 0 out, the spread, that 0 is definitely an outlier, and it's going to make that MAD go lower. So I'm going to erase this for a second. So imagine that this was your test scores and we took this out, right? It would definitely bring your test scores, you'd be more consistent. It would make it look more consistent. Okay, as opposed if I took the month of May out from this side, if I took a 9 out from this side, it's not going to make, might make a little difference, but not make a considerable amount of distance. Okay, so the effect would definitely be more, felt more on city A. Okay, use the box and whisker to answer the following questions. How much greater is the median salary of worker A than the median salary of worker B? So let me write down worker A here. A and worker B. And I'm going to write median. So the median salary for worker A, the median is this guy right here, right? So let me change colors. That's the median, and he makes 175. The median salary for worker B is 125. So okay. So how much greater is the worker A than worker B? So worker A makes how much more? 50 bucks more. What's the interquartile range for worker A? Well, the interquartile range for worker A, right, is Q3, which is right here, minus Q1. So it's 200 minus 125. That gives us 75. Worker B, change colors, is the Q3 is this one, right? The big size. So we're talking about the size of the box, right? 175 minus, and what's Q1? 100. And that gives us 75. So that's the interquartile range for both, which are the same. What percent of workers B earning fell between 75 and 100? So let's look at the graph again. Worker B, from 75 to 100 is this stretch right here, and that stretch only. And if you remember what we talked about, that represents, remember, each part represents 25%, 25%, 25%, 25%. So that from 75 to 100 represents 25% of his weekly earning. What about between 100 and 175? Well, between 175, I'm going to change colors, is from here to here. Right? So we have two groups of 25, so that represents 50% of the earnings. We have more. Workers A. What's the percent of workers A earning fell between 100 and 200? For worker A, between 100 and 200, let's see, 100, which is right here, and 200 over here. So that's this 25%, this 25%, and that 25%. So that represents 75%. Between 125 and 75, so between 125, let me erase that, 125, which is right here, starts right here, so, and 175, so it's just that stretch right there, right? And that's only 25%, so the second part would be 25%. 5, use the the box and whisker to decide if each statement is true or false. Okay. Group A's median is greater than Group A. False. Right? Group A, here's the median. Group B's, here's the median. Definitely Group B is bigger. Group A's range is greater than Group B range. So we're talking about range here. Okay. So range is this, the highest and the lowest, right? So I don't even have to calculate it because I know it looks like, not looks like, but A goes all the way to 82, whereas B only goes to 81. So that's definitely true. 75% of Group A falls between 76 and 81. So 76 and 81 in Group A. From here to here, is that 75%? Yeah, because that's 25. That's 25. That's 25. So that's definitely true. 25% of Group B falls between 77 and 80. So they're saying that from here to here is 25%. Well, this is 25% and this part is 25%. That actually is 50%, so this is false. And the interquartile range is the same for both groups. Well, the interquartile range for Group A is 81, right? Q3 minus 78, which is 3. And then the interquartile range for Group B is 80 minus 77, which is also 3. That is true for both. Six. Use the box and whisker plot to decide whether Amy or Ed is the answer to the question. Okay. Who has a greater mean absolute deviation? Ooh. So that one is Ed, because you can see that Ed, the data is spread out more, right? So again, remember that absolute deviation, the more spread out your numbers are, the bigger it's going to be, right? So that's definitely Ed. Who has a greater median? Well, Amy, because her median is here, and Ed's median is here, so Amy wins. Who has a lower extreme of 76? Who has a lower extreme of 76? So, lower extreme, all the way, also known as your min. Who has a minimum value of 76? Well, Ed's minimum value is 70. Amy's minimum value is 76, so that would be Amy. Who has a greater interquartile range? Well, that's, in other words, who has a bigger box, right? So without even calculating who has a bigger box, it's clearly that Ed has a bigger box here. If you were to calculate Q3 minus Q1 for both, you would find that Ed had that. Okay. Okay. So there's a survey done about students. What sports students like. Assuming the survey was random and unbiased, use the data in the table to answer the questions. The population is 850. He surveyed 34 students. Okay, how many students would you expect to select basketball as their favorite? So in my survey, 8 students liked basketball out of 34. Then multiply by the number of students in the school, and I will do that 8 times whatever that is, 850 divided by 34, and we're gonna get about 200 students like basketball. 2. How many students would you expect to select football? So in my survey, 14 people out of 34 selected football. Let's multiply that by 850. And 14 times 850 divided by 34, and we get 350. Is there more? Yeah, there is. And how many students would you expect to select baseball? Yes, baseball. So in my survey, baseball, 3 people selected baseball as their favorite sport out of 34. So let's apply that to the student population, and we multiply that by 850, and we're going to get 3 times 850 equals divided by 34 equals only 75 kids out of the whole school would select baseball. Okay, that's kind of simple. 8. What's the math for this data? So again, just another math problem. So the first thing we have to do is find the mean, and let's add this up. So we get 12, 22, 22 and 5 is 27. We get 40. Divided by 5, so the mean is 8. Now remember, to calculate the MAD, we have to subtract, right? So we got to find the distance. Every point here is away from 8. So to calculate the distance, so I'll just write distance. I'm going to add that, right? So 6, how far is it away from 8? 2. 13, how far is it away from 8? 5. 6, again, how far is it away from 8? 2. How far is 5 away from 8? 3. And how far is 10 away from 8? 2. Remember, distance can't be negative, so that's why it's all positive. And then we're going to add all that and divide by 5, and that's going to give us our MAD. Right, so 2, 5, 10, 14 divided by 5, and we get our answer as 2.8. So our MAD is 2.8. Okay, which is not that bad, I guess. I mean, there's no bad or good here. It's just that they're not too far from the mean. Okay, so she wants to know what music is most popular among high school students. She wants to conduct a survey that is unbiased. That's a fair survey, right? And truly represents her high school. Which of the following describes how Julie should collect her data? Place an ad in the newspaper and ask students to reply to a survey. No, because only the people who are interested will reply. Okay, so that's going to already be there's going to be a bias there. So the first one is no. 2, by serving every 5th student in the band, chorus, or choir. Also no, because you're limiting your selection to these 3 groups. Okay. Selecting every 20th student who enters the school. That's definitely seems fair. Random, right? And everybody has a chance to be selected. There's no bias to a particular group. And by passing out surveys to the students at an honor roll breakfast. Definitely no, because again, you're limiting your choices to the honors kids. Okay. 10, box and whisker. How much greater is the median weight of the dogs in Pet Store 2 than Pet Store 1? Wow, so difficult. So Pet Store 2, the median, which is this line here, so the median is 75. Pet Store 1, the median is this line here, right, at Q2, and that looks like 65. So how much bigger is the weight of the dogs in Pet Store 1? Well, 75 minus 65, they're 10 pounds bigger. Okay. Ow, 75 pounds for a dog? Jeez. Like a bear. Teacher randomly grades 5 students' homework assignment. She finds that 2 out of 5 students make surveys, so make mistakes. So 2 out of every 5 students make mistakes. So if she's going to grade the rest of her homework assignments, which 65 more, how many of those 65 should she expect to have mistakes? Well, it's not. I think that gives us 26. So out of the 65, 26 would have mistakes. How many hours a week they spend studying? Here's the answer. Based on the data, he made a list of inferences. Which inference is not correct? Okay, 25% of 7th graders study less than 16 hours a week. Well, this group here. Now let me put 25%. Let me put 25%. Okay. So is it true that 25% study 16 hours or less? Well, here's 16, and that way. Right? So that's definitely true. 75% study less than 26 hours a week. Well, let's find 26, and 26 is here. Anybody who studies less than that would be this group, and this group. Would that equal to 75? Yes, so that's also true. True and true. 7th grade students study for a median of 22 hours a week. Well, the median is right here. Right? Is that 22? Yeah, that's true. And 50% of 7th grade study for more than 16 hours. Well, more than 16 hours is this and above, right? So it's this group, that group, and that group. And that's definitely not 50%. That equals 75%. So this one was the one that's not true. Maria. Maria wants to know how many students in her school plan to attend this opening night perform at a high school play. To best predict attendance, where should Maria pull a random sample of studies to survey? The official enrollment roster, which means the list of all the school students in the school. Students waiting for the bus. So this is a yes, right? Because everybody participates here. Students waiting for the bus after school? No. In her theater practice? Definitely no. Biased. And in the computer lab before school? Also, I don't know, that would be biased. So the only place that is fair to take a random sample would be from the whole list, right? No group is favored here. Take it below again. Guys, I gotta stop this. I'll stop at 14 and I'll continue. Okay, so I am doing from 14. I think I have it on the first video. Oh my god, FYI, I know it's late, 7:42 on Friday. I spent the past hour looking for the other video because I threw it away in my laptop thingy, so I was able to retrieve it. Nevertheless, not too happy with myself for not saving it to begin with. So all right, let's just continue. So 15, he recorded the number of minutes it takes for boys and girls in his PE class to complete one lap. So which statement is true? Okay, so the mean absolute deviation for the girls' data is greater than for the boys. No, because it's more spread out here for the boys, so the MAD would be greater for the girls, right? So the girls' MAD, now write the girls' MAD is less than the boys' MAD, right? Right. Remember, it's MAD calculates the distance you are from the mean, although this is showing the mean, but you can tell that the boys' data is really spread out. Being absolute deviation of the boys is greater than the girls, yes. So that's okay. Let's see if the other ones are false anyways. The median for the time of the boys is greater than the median time of the girls. That's not true. So that's not. Okay, so far we're good. The interquartile range for the girls is greater than the boys. And again, the IQR here is the size of the box, right? You can just visually see that the size of the box for the boys is greater. So that's also not true. And all of the above are true. So that's garbage. And we were correct. And it was this one. Okay. 16, the box and whisker plot shows the class test scores. Decided to give the students with scores in the top 25 a treat. So the top 25, which is this group here, will get a treat. Right, they will get a treat on the right there. What scores did students have to get in order to receive the treat? They got, now you can guess scores from 80 to 90%. So the kids who got anywhere from 80 to 90, which was the top 25% of the class, would get a treat. That's nice. 17, reporter asked 75 kids if they're going to be traveling. Students who responded that they would be traveling were asked whether they would be traveling by plane. Okay, the table shown below. Okay, so 75 kids, and how are they going to travel, right? So 34 not travel, some by bus, plane, car, train. All right, so based on those results, how many would I expect from 480? So we had a sample here. And the sample was out of 75, and we're talking about by plane. And our sample by plane, 10 people said. So 10 out of 75 in our sample are going by plane, and I applied that to the entire population. And I'm going to get some number which I have no idea what it is. So 4,000, 4 times 4,000, 10 times 480, divide that by 75, approximately 64 I should expect would also be traveling by plane out of all the 480 in the school. Okay, so 18, box and whisker. Okay, so we have 3 questions based on that. Students, what is it, the distance? Students live from school. Okay, so let's answer ABC. What is the median distance? Okay, really? The median is 9, so that was easy. What's the interquartile range? Which is 13 minus 5, which is 8, so that's this one. What percent of students live 5 miles or more from school? So anybody that lives 5 miles or more now share will be this group, and this group. And since they each represent 25%, right, we have a total of 75. Okay, so again, pretty simple for you guys. 19. Table below shows the first 3 scores. What was the score? What score does she need to take on the fourth to bring her average to a 90? So, right. So in order to get a 90 on the first and the last test, let me write this down algebraically. This has to be 85 plus 93 plus 88 plus this last test score, right? We're going to divide all that by 4, and that has to equal 90. Now, if we cross multiply, I'm just going to simplify things a little bit. If I cross multiply, right, and I'll put this over 1, cross multiply that and cross multiply this. So on one side I get 360, and on the other side I'm going to get, and I'm just going to add 85 plus 93 plus 88, and that's going to give me 266 plus x. So what does she have to get here? So if you subtract that from 360, she has to get a 94% on her last test, so that she can come up with an average of 90. $20, again a box plot question. Okay, so I'll just try to make this, I can see the whole thing. All right, okay, so which statement is true? The range for class 1 is larger than the range for class 2. That is definitely not true. And we're not talking about IQR, we're talking about the range. And you can say that class 1 has a range that is smaller than class 2, right? It's the highest minus the lowest. So that's garbage. The median for class 1 is larger or larger. And the median for class 1 is here and definitely larger than class 2. So that's true. We have to do the rest. Well, let's continue. The MAD for class 1 is greater for the MAD of class 2. That's not true because you can tell that the data here is more clustered, right? It's tighter, so the MAD of class 1 will be less than the MAD of class 2, right? You can tell because of how spread the data is. The interquartile range of class 1, which means the box, right? Q3 minus Q1 is greater than class 2, and you can visually see that the box of class 1 is definitely not bigger than class 2, so that's also garbage. So again, our first answer of B was correct. 21, box and whisker show the weekly earnings for worker A and B. How much greater is the median salary for worker A? So worker A, the median, and we're going to write that the median looks like 175. And worker B, the median is 125. So if we subtract that, we get that one. Okay, Edgar earned the following score in his first 10 tests. Which one will be affected if he earns a score of 50 on his next test? Well, if he earns a 50, what ends up happening is that his mean, his average, definitely goes that way, right? The mean doesn't matter. Sorry, the median doesn't matter because, you know, if we line this up from least to greatest, what ends up happening that gets crossed out, right, as we work towards the middle. So it doesn't affect the median at all. So anything that says that it affects the median, you can throw it out. So this one is out, this one is out, and the only one that it really affects is the mean. Okay, this is definitely would be an outlier. 23. Joseph's final average, that should say final average, okay? Final average in science class are shown below. what is the minimum grade he can get in his final to get at least 90 for his final grade. What? Percentage toward final grade 20, 20, 40, 20. Ooh, hang on a second. What is the minimum Jet can get in his final grade? What? I should look at these questions when I assign it to you. He needs to get a 9. So hang on. I'm trying to figure out how to calculate this. So here he got 90. His homework grade, he got 93% of 20 points, right? I don't know how to calculate this. So let me see what he has. So 93%, 0.93 times 20. So out of the 20.93, 0.93 times 20 means, what the heck? 0.93 times 20. So out of the homework, all the 20 available homework points, he has 18.6. Quizzes, he has 92% of 20, which is 18.4. And then the tests, right? So the tests, what do you have? He has 35% of 40. What the heck? Hang on a second, guys. Am I doing this right? Test, he has, the average is 35. So his test is out of 40. So he has 35, and that would be just 35 out of 40. So we need to use the top. So that, and he wants that to equal, what is he wants? A 90. He wants a grade of 90. So in order for him to get a grade of 90 for his final grade, what does he have to get on the exam? So 18.6 plus 18.4, 18.6 plus 18.4 plus 35, enter, equals 72, minus 90, he needs to get 18. So he needs 18 points. Okay, so 18 out of 20. What's 18 out of 20? Would be 90. So he needs to get a 90 on his final exam, right? And 90% or 90 of 20, 0.9 times 20, which gives you 18. Yeah, he would need a 90 on his final test here to give him 18 out of 20 of on his final exam to get a final grade of 90. Okay. Ugh. 24. Ooh. What is the difference between the median number of turkey sandwich sold and the median number of ham sandwich? Oh, okay, we have to list them up. So turkey, 7, 8, 12, 13, 15. All right, turkey. And the median is 12. Okay, ham, okay, that's not that bad. 6, 8, 9, 11, 16. The median is, what's the median? 9, so the difference is, the answer to the question is 3. Oops, 3. Okay, it's time for me to put your bonus point. It's called SRNE. It's a ticker symbol, okay, in the stock market for a company that was pretty big on Friday today. Came out of the news that they found the antibody that is that cure that's it's like 100% effective against the coronavirus. It was just a So it hasn't. It's in the lab. They were 100% successful. So they have to translate that now to. You have to do testing on animals, and then after testing on animals, obviously, if they get all approvals, they would go to human trials, right? But that's still a little bit way off. But it became news. There were a lot of news on this. So that's the stalker symbol, and you can find out more if you what do you call Google that SRNE. Okay. 25. She wants to know the favorite food of middle schools in her school. Which activity will give her the best information? Ask every student in her math class. No. Biased. Ask all the teachers in her school. Definitely not. Observe the students in her school cafeteria for a week. No. She surveys every 10 students living in her school cafeteria. That's probably the one that wrote. Okay. You don't observe people eating. 26. What percentage of the height of the students is between 60 and 65? Okay, these are really easy questions, right? So we want this group here, between 60 and 65, and they make up 50% of the population. So anything that's not in terms of 25, 50, 75, or multiple 25, you can automatically throw in the garbage. 27, box and whiskers again. What's the range? Okay, so don't confuse that with interquartile range. Okay, so we're asking for range. So the range is the highest, max minus the min, and that's going to give us somewhere in the 70s or something. So obviously the only one that's available is 78. Okay. 28, another box and whisker. I guess you can. I'm getting hints. Blah blah blah. Box and whisker. Oh, I forgot the question here. Oh, I know I said something in class. Like, what represents? I think the question that we said, or I hopefully, what percent, which interval, which range here, which I'm gonna write which range. I'm gonna make one up. Which range? I'm trying to be a little bit different. Which range reflects 75% of the data? Okay, and I think I said 50% in class, but it doesn't matter. So if it was 75% of the data, which one would this be? Well, not 38 to 54. It's too short. 38 to 81. Well, this one's 38 to 51. 81 goes all the way here, and that would be the answer, right? Because that would be 25%. This 25%, that 25%, and they're all. That represents 75% of our data. Right? 29. The range of the number of students in the class is 13. Okay, so the highest minus the lowest has to give you 13. And the median has to be 9. So which of these would have that? So anything that has a median of 9, not have a median of 9, I'm just going to cross out. So this doesn't have a median of 9. This one doesn't. So it's between A and B. Which one has a range of 13? And the only one that has a range of 13, this one is 19 minus 6, right? Highest, max, minus the min. And it's 19 minus 6, which gives us 13, which makes that our answer. And finally, or not, 30, it's a vertical. So we have the temperature of 2 cities. Which statement is supported by the data? Okay, Sunnyvale has the lowest temperature. False. Marytown actually does. That's garbage. Marytown has a greater interquartile range. Marytown, yeah, look at the box. It's definitely bigger than the box in Sunnyvale, so that's true. The median temperature is the same for both. The medium, one's medium is here, one medium is down here, so that's not true. And Marytown has a greater range of noon temperatures. Greater range of noon temperatures. No, because the range here, what is this? 56, 57, 58, not 58. And that's 70, which makes that 12, right? The range. This one is, looks like 59, and that's 70, 71, 72. And what is this? 11? No, 12, 13. Is that 72? 71, 72. And is this 59? We can make a case for 59, right? So 6 minus 5 is 13. Marytown has a greater range, and it doesn't because it has 12. The range is 12. And Sunnyvale is 13, the range, right? So that's also not true. So the only one that's true is 2. Okay, that's about it. That's what your tests pretty much look like. I think you have a MAD question as a part 2 question. Okay, you're gonna create a MAD of 2 different set of data and then compare. And then one other question deals with talking about, again, comparing 2 sets of numbers. And let's say here are 2 sets of numbers. Compare their means and discuss them. Compare their medians and tell me, and discuss them and stuff like that. Okay, so that's it. I will be posting this pretty soon.